This is TechCrunch. Fusion energy startup Helion announced on Friday that it has hit a key milestone in its quest for fusion power. Plasmas inside the company's Polaris prototype reactor have reached 150 million degrees Celsius, 3/4 of the way toward what the company thinks it will need to operate a commercial fusion power plant. David Kirtley, Helion's co-founder and CEO, told TechCrunch, "We're obviously really excited to be able to get to this place." Now, Polaris is also operating using deuterium-tritium fuel, a mixture of two hydrogen isotopes, which Kirtley said makes Helion the first fusion company to do so. He said the company was able to see the fusion power output increase dramatically as expected in the form of heat. The Everett, Washington-based startup is locked in a race with several other companies that are seeking to commercialize fusion power, a potentially unlimited source of clean energy. That potential has investors rushing to bet on the technology. This week, Inertia Enterprises announced a $450 million Series A round that included Bessemer and GV. In January, Type 1 Energy told TechCrunch it was in the midst of raising $250 million, while last summer, Commonwealth Fusion Systems raised $863 million from investors, including Google and NVIDIA. Helion itself raised $425 million last year from a group that included Sam Altman, Lightspeed, and SoftBank. While most other fusion startups are targeting the early 2030s to put electricity on the grid, Helion has a contract with Microsoft to sell it electricity starting in 2028, though that power would come from a larger commercial reactor called Orion that the company is currently building, not Polaris. Every fusion startup has its own milestones based on the design of its reactor. Commonwealth Fusion Systems, for example, needs to heat its plasmas to more than 100 million degrees Celsius inside of its tokamak, a donut-shaped device that uses powerful magnets to contain the plasma. Helion's reactor is different, though, needing plasmas that are about twice as hot to function as intended. The company's reactor design is what's called a field-reversed configuration. The inside chamber looks like an hourglass, and at the wide ends, fuel gets injected and turned into plasmas. Magnets then accelerate the plasmas toward each other. When they first merge, they're around 10 to 20 million degrees Celsius. Powerful magnets then compress the merged ball further, raising the temperature to 150 million degrees Celsius. And it all happens in less than a millisecond. Instead of extracting energy from the fusion reactions in the form of heat, Helion uses the fusion reaction's own magnetic field to generate electricity. Each pulse will push back against the reactor's own magnets, inducing electrical current that can be harvested. By harvesting electricity directly from the fusion reactions, the company hopes to be more efficient than its competitors. Over the last year, Kirtley said that Helion had refined some of the circuits in the reactor to boost how much electricity they recover. While the company uses deuterium-tritium fuel today, down the road, it plans to use deuterium-helium-3. Most fusion companies plan to use deuterium-tritium and exact energy as heat. Helion's fuel choice, deuterium-helium-3, produces more charged particles, which push forcefully against the magnetic fields that confine the plasma, making it better suited for Helion's approach of generating electricity directly. Now, the company's ultimate goal is to produce plasmas that hit 200 million degrees Celsius, far higher than other companies' targets, a function of its reactor design and fuel choice. Kirtley said that he believes that at 200 million degrees, that's where you get into that optimal sweet spot of where you want to operate a power plant. When asked whether Helion had reached scientific break-even, that's the point where a fusion reaction generates more energy than it requires to start, Kirtley demurred, saying that they were focusing on the electricity piece, making electricity, rather than the pure scientific milestones. Helium-3 is common on the Moon, but not here on Earth, so Helion must make its own fuel. To start, it uses deuterium nuclei to produce the first batches. In regular operation, while the main source of power will be deuterium helium-3 fusion, some of the reactions will still be deuterium on deuterium, which will produce helium-3 that the company will purify and then reuse. Work is already underway to refine the fuel cycle, with Kirtley saying it's been a pleasant surprise in that a lot of that technology has been easier to do than maybe the company expected. Helion has been able to produce helium-3 at very high efficiencies in terms of both throughput and purity. While Helion is currently the only fusion startup using helium-3 in its fuel, Kirtley said he thinks other companies will in the future, hinting even that he'd be open to selling it to them. He said other folks, as they come along and recognize that they want to do this approach of direct electricity recovery and see the efficiency gains from it, well, they'll want to be using helium-3 fuel as well. Alongside its experiments with Polaris, Helion is also building Orion, a 50-megawatt fusion reactor it needs to fulfill its Microsoft contract. Kirtley said that the company's ultimate goal is not to build and deliver Polaris. That's a step along the way towards scaled power plants. That's it from TechCrunch. For more stories like this one, go to TechCrunch.com.